This is Algebra 1, Unit 9, Lesson 5, Finding Zeros by Completing the Square. Okay, now that we know how to solve by using inverse operations, you can use this to find square roots to find its zeros of a quadratic function. Usually when a quadratic function is in vertex form. So if you have a quadratic that looks like this, y equals a times x minus h squared plus k, we can use square roots to find its zeros. Okay, so if we have y equals 2 times x minus 2 squared minus 36, to find the zero, remember this is going to be the x-intercept. That's where y is going to equal 0. So if we plug in 0, we have 2 times x minus 2 squared minus 36 is going to equal 0. Now it says simplest radical form. So the first thing we're going to do is solve this for x. Add the 36. Okay, then we have to divide by 2 to get the square by itself. Equals 18. All right, then we want to take the square root of both sides. Once we do that, x minus 2 quantity squared is equal to the square root of 18. The square root cancels out the square, leaving just x minus 2 is equal to plus or minus the square root of 18. All right, now remember the square root of 18 has a perfect square in it. What perfect square goes in 18 is 9. So this is going to be x minus 2 equals plus or minus the square root of 9 times 2. The square root of 9 is going to be 3. So this is going to be plus or minus 3 times the square root of 2. And then we have to move the 2 over. So we're going to add the 2. Now remember it goes in front there. So we have actually x is equal to 2 plus or minus 3 times the square root of 2. That is simplest radical form. Okay? It's because we can't break down the radical any farther. But then it says find the roots to the nearest tenth. All right, now remember there's actually 2 roots there. There's 2 plus 3 times the square root of 2. And there's also 2 minus 3 times the square root of 2, which are both irrational answers. So what we have to do is put each one of these in the calculator. All right, let me grab my calculator. 2 plus 3 square root of 2. And that gives me approximately rounded to the nearest tenth, approximately 6.2. Okay, so this first one is going to be 6.2. All right, then 2 minus 3 times the square root of 2. I'm going to go up here and grab this so I don't have to retype it. Press enter, and then go back here, change the plus to a minus. And I get negative 2.2 is my second term. All right, so negative 2.2 is my second zero. So if I were to graph this, this is going to cross the x-axis at approximately 6.2 and negative 2.2. Okay, and if a quadratic is not in vertex form, we can use completing the square to get the quadratic in this form and find the zeros, okay, or the roots. So we can do this either by factoring, which would be x squared minus 6x minus 16 is equal to 0, where we use our box, because our roots on this are going to be rational. All right, let's take a look at this. This is going to be x squared and negative 16, x and x, make my bubbles. And this is going to be negative 8 and positive 2 to give me negative 6 in the middle. So that gives me x minus 8, x plus 2, set them equal to 0. Oops, that's an 8. And then solve for x, add the 8. X is equal to positive 8, and then subtract the 2. X is equal to negative 2. Okay, so we can solve it by factoring. That's usually your first line of defense. But you can also do it by completing the square. Remember we did completing the square a few weeks ago? X squared minus 6x minus 16 is equal to 0. That's when you move the c term over. And then you take half of the b term and square it. So what's half of negative 6? It would be negative 3. And we're going to square that and add it to both sides. So add negative 3 squared, both sides. And that gives me x squared minus 6x plus 9 equals 16 plus 9. Okay, now this is going to factor as what this is here squared. It's actually going to be x minus 3 squared is equal to 25. All right, once we get it to this form, doesn't that look like what we did on the other homework? Yeah. So this is squared, so we can take the square root of both sides. X minus 3 equals plus or minus the square root of 25. So that gives me x minus 3 is equal to plus or minus 5. Okay, so that's my two answers. X minus 3 equals positive 5, and x minus 3 equals negative 5. So we want to add the 3 on both sides, and we get x equals 8. Add the 3 here. We get x equals negative 2. So I got the same answers, I just did it by completing the square instead. If given a choice, if you can factor, factor. If you can't, use completing the square. Because both methods will work to find the roots, but sometimes the roots can't be found by factoring because they are irrational. If something does not factor, you can use completing the square. All right, how do you tell if it can work or not? Well, a lot of times you may see this. Find the roots of y equals x squared plus 6x plus 2 in simplest radical form. That is usually a tip-off that this is not going to factor. And this one doesn't factor. There's no factors of 2 that will add up to 6. So if we set this equal to 0, okay, let's use completing the square and then set round to the nearest tenth when we're done after simplest radical form. So completing the square, subtract the 2, because we have to move the c term to the other side. X squared plus 6x is equal to negative 2. Take half of the b term, which would be the 6, and square it. So half of 6 is 3 squared. Add it here, and we also have to add it over here. Okay, that gives me x squared plus 6x plus 9 is equal to negative 2 plus 9. Okay, half the b term squared. All right, now remember the trick. Whatever this is with the same sign is going to be the factors of x squared plus 6x plus 9 squared. So that's going to be x plus 3 quantity squared. And negative 2 plus 9 is 7. Okay, so now this is a square by itself, so we can take the square root of this side equals plus or minus the square root of this side. And that gives me the square root cancels out the square, leaving x plus 3 equals plus or minus the square root of 7. And then subtract the 3, and we get x equals negative 3 plus or minus the square root of 7. Now that is simplest radical form. That's this right here. And it says then round to the nearest tenth. So remember, there's actually two answers here. Negative 3 plus the square root of 7. And there's also negative 3 minus the square root of 7. And you're going to need your calculator for this. So if I do negative 3 plus the square root of 7, I get negative 0.35 rounded to the nearest tenth is going to be negative 0.4. All right, so this is going to be approximately negative 0.4. All right, then I want to do negative 3 minus the square root of 7. Negative 3 minus the square root of 7. And that gives me negative 5.64 rounded to the nearest tenth is negative 5.6. Okay, so if you have simplest radical form, leave the radical in it. If it says to round, round to the place that it's given. Remember, you always have two answers when you do this. Okay, so if we have f of x equals 2x squared minus 4x minus 16, let's see what we remember. What is the y-intercept? All right, remember when the y-intercept is when x is equal to 0, that's actually going to be the c term. So the y-intercept is going to be at 0, negative 16. You can plug in the 0 and you can see it's going to be the c term. All right, now let's write the function in vertex form. So vertex form, remember, is going to be y equals a times x minus h squared plus k form. We want this to look like this. So if it says vertex form, you're going to have to complete the square. All right, now remember, when you do this, you have to remember to divide through by 2 first. So if you have f of x, you're going to have to divide by 2 on everything. Let me do it this way. You're going to have to divide by 2 first. 2x squared minus 4x minus 16. Divide by 2 first. All right, so that gives me f of x over 2 equals x squared minus 2x minus 8. Okay, so now we have the x squared down to a 1 for the coefficient. So now we want to move the c term, move the 8 over here. F of x over 2 plus 8 is equal to x squared minus 2x. All right, now take half of the b term. This is the b term. Half of that would be -1 and squared. Add it to both sides. All right, let me put it up here. F of x over 2, we'll worry about that later, plus 8 plus -1 squared is 1, is equal to x squared minus 2x plus 1. Okay, so when I combine my terms and factor, x squared minus 2x plus 1 will factor as x minus 1 squared, because that's what we took half of. This side will be f of x over 2 plus 9. All right, then we have to move the c term back over. Minus 9 is equal to x minus 1 squared minus 9. And then I want to remultiply by 2 on both sides. Now remember, the 2 is going to distribute here and here. It can't go through the parentheses because of the squared, so this is just going to be f of x is equal to 2 times x minus 1 squared minus 9 times 2 is 18. Okay, so if you remember vertex form, what's the vertex of this parabola? The vertex is going to be opposite sign here, 1, and then same sign here for the y, -18. So there we go. So your vertex is going to be at 1, -18. All right, now let's find the zeros of the function using vertex form. Okay, so we said the vertex form that we just found was 2 times x minus 1 squared minus 18, and then if you're using the zeros, you want it to equal 0. So how do we solve this? Well, first thing we do is we add the 18, and 2 times x minus 1 squared is equal to 18. Divide by 2, and that gives me x minus 1 squared is equal to 9. Now we can take the square root of both sides. Don't forget your plus or minus. X minus 1 is equal to plus or minus, what's the square root of 9, is 3. So that means x minus 1 is going to equal 3, and x minus 1 is going to equal -3. So if we add 1 to both sides, x is going to equal 4, and x is going to equal -2. So that means our zeros are going to be at 4 and -2. So that means, could this have factored? Yes, it will. If you factor the original equation, 2x squared minus 4x minus 16 is equal to 0, we can divide everything by 2. And you get x squared minus 2x minus 8 equals 0, which factors as x minus 4x plus 2. I'm just doing this quickly. And then x minus 4 equals 0, x plus 2 equals 0, x is equal to 4, and x is equal to -2. So I get the same answers. Which one would be easier? I'd probably use factoring if I had the chance. But if you're in the vertex form, you can do it that way. All right, so we can actually go on to the last problem. Okay, so the quadratic pictured has a leading coefficient of 1, so that means your a value is going to be 1. All right, the equation is in vertex form. Y equals a times x minus h squared plus k. We know a is going to be 1. All right, now what is h and k in vertex form? Isn't that the vertex? Well, h and k, and this one is going to be what the vertex is. What's the vertex right here? Is going to be -1, -4. All right, so if I plug this into here, remember, it's always going to be opposite sign for the h, so it's going to be x minus minus 1, which gives me x plus 1 squared, and then plus k would be plus -4. So there is my vertex form. I didn't even have to complete the square. I could figure it out based on that. All right, write this equation in factored form. All right, factored form means that you had the zeros. What are my two zeros? My two zeros are x equals -4 and x equals 1. What bubbles would give you x equals -4 when you set it equal to 0? Well, wouldn't that be x plus 4 equals 0? Yeah. And this one would be x minus 1 is equal to 0. So I could write this as y equals x plus 4 times x minus 1. And if I multiply this out,